Namaste everyone. In this problem we are going to solve a problem on kinematics, especially related to curvilinear motion. So we have been given a question here like this. There is a projectile, which means an object moving under the effect of gravity, and it is fired from a point O with the same velocity as it would the velocity will be given by an object which is dropping from a height of 100 meters. So let us assume an object over here like this, and it is falling from this height here, and initial velocity with which it is going to fall, of course, it's going to be 0, and when it reaches down here, its final velocity will be given by the equation this 2gh under root. So now this is the velocity with which our object is fired. So now let us assume the point O over here, and from here the object has been fired at some angle, and the velocity with which it is fired is given by this formula. And now it's going to follow a path, a parabolic path like this, and we have been told that it hits a point which is like this below the point of origin, and the distance which it is below that point is 50, and the horizontal distance between the point of projection and the point where it reaches is 100. So we have been told to find the angle at which we have to fire it such that it reaches our destination. Now, for those who didn't understand how we got this relation, we have used the third equation of motion, which is v square minus u square equal to 2as. So here the initial velocity is 0, so this is going to cancel. Acceleration is equal to g, and h is the height from which it is falling. So the height here has been given to us, that being 100 meters. So let's go ahead and find the velocity. This is going to be 2 into 9.81 times 100 under square root. So when we feed it in the calculator, we get 44.29. So 44.29 meters per second. This is the velocity with which we have to fire the ball in this particular direction. And now we are supposed to find the angle theta at which we need to fire so that it's going to reach this point. So if you take the coordinates of O as 0, 0, then the coordinates of this particular point is going to be 100, 50 in the downward direction, so it's going to be negative 50. So these are the coordinates. Now if you remember the equation of our parabolic path, this is what it is. So we have the relation between y and x given by this particular equation, and we know a few coordinates on this. So 0, 0 is of course one of the coordinates, the second coordinate being 100, minus 50. So let us substitute these coordinates into our equation, and that's how we'll proceed. So 50 and x value is 100, so 100 tan of theta minus of x square, of course, so x is again 100, so 100 square into 9.81 divided by 2 times u square, u being 44.29, square of that into cos square theta. So theta here is the unknown, so instead of having cos theta at the bottom, we can take the reciprocal of that. Reciprocal of cos, 1 by cos is sec, so 1 by cos square will be sec square of theta. So now let's proceed to simplify this equation a bit. I'll take the calculator. So when we calculate this particular coefficient, we get this value. Let's write it down. So minus 50 as it is, 100 tan theta, minus, we are getting 25.00, so we'll just round it off to 25 times sec square. So now sec square can again be written as 1 plus tan square theta. Fine. So that's what we're going to do. So now let's divide all these terms by 25 to simplify this term. This will cancel all together. Here we get 2, here we are left with 4. So we get minus 2 equals 4 tan theta minus 1 minus tan square theta. So now let's bring it in the format of a quadratic equation. So we get tan square theta minus 4 tan theta, and minus 1 when it comes to this side, we are left just with minus 1 here, so equal to 0. So this appears to be a quadratic equation, except that in place of x we have tan of theta. So if you have the scientific calculator, you have the direct way to find the roots, you can use that. And if you don't have access to that, you can just directly use the relation x equals minus b. In this case, b is 4, so minus b is going to be 4, plus or minus b square, that is 16, minus 4ac, a into c is minus 1, so it's going to be plus 4 under root whole divided by 2 times a, so that's just going to be 2. So this, when we find, we will get two values for theta, two values for tan of theta, let's find it out. So here you can see we are getting 4.24, so 4.24 as one of the answers, and the second answer we're going to get by putting a negative sign here, which gives us 0.24, that is of course negative. So when we put tan inverse function, we will get the values of theta, we'll get two values of theta. So you can see tan inverse 4.24 is giving us 76.73 degrees, and tan inverse of the other value is giving us negative 13.5 degrees. So now what's the meaning of the angles being positive and negative? So it means that this angle is above our x-axis, our horizontal axis, and this one is below the horizontal axis. That means the path that we get over here is actually fired at a negative angle, right? So at a negative angle, so this negative angle being given. So these dotted lines in orange shows the path that it is going to take, and you can see both these paths are actually ending up at this point, our target, and that's the solution to our problem. Coming to the final thing that is asked in the question, we have been asked to prove that they are actually at right angles to each other. So that for that we'll just have to subtract these angles. So 76.73 minus 13, okay, actually minus or minus becomes plus, so that's approximately going to give us 90 degrees. So you may argue that it's approximately 90 degrees, so how is it exactly proved that it is exactly 90 degrees? So if you want exact answers for yourselves, instead of feeding these rounded off values, I suggest you feed this complete term instead of tan inverse, and that is actually going to give an more exact values. And when we use these more exact values, that's when you actually end up getting the angle difference. So angle difference between these two is going to be much nearer. Okay, so this is going to be much nearer to what we need. So you can see it's 89.999, so it's very close to 90 degrees. So that's it for this video. In the next one we'll take up another one. Thank you.